This is 4.3 Laws of Logs, and I'm going to start off with some formulas here or rules that you should have seen before, and if not, you need to memorize them. Starting off with log base A of x times y, you are going to get log base A of x, and that's going to be plus log base A of y. If you have a log base A of x divided by y, that's going to be log base A of x, and that's going to be minus log base A of y. When you have log base A of x raised to the k, your k is now going to become your coefficient. So it's going to be k times your log base A of x. Now I wrote this out in natural log as well so that you could see that these same rules apply to the natural log. So natural log of xy is still natural log of x plus natural log of y. And then natural log of x over y is still natural log of x minus natural log of y. And then when you have natural log of x raised to the k, your k becomes the coefficient, so it's k times natural log of x. And again, like I said, these are things that you need to memorize so that you can use them in solving your equations. Okay, and here's a little statement. It's kind of a duh statement, I think. If log base A of x is equal to log base A of y, then I can safely say that x is equal to y. And I think some of y'all have already seen this when you're solving your equations. Your log base a's fall out and x is going to be equal to y. And I can safely say this because this is a one-to-one function. And this can go either way. If x equals y, you can plug in a log and say that this goes the other way as well. Okay, now let's use our laws to expand this equation here. So log base 5, and you've got a multiplication here. So the first thing that we want to do is apply our log base 5 to both of these. So this would be log base 5 of x to the third plus log base 5 of y to the sixth. Now if you notice I have an exponent, and your exponent rule says to bring that down in front. So this would be 3 log base 5 of x plus 6 log base 5 of x. And that's all that I could do. That would be my answer. And again, this holds true for natural log as well. Okay, for this next problem, this is a natural log, and I do have a multiplication on top. So remember, multiplication would mean addition, and addition down here as well. And then my division would be subtraction. Okay, so I'm going to work this out. Let's start off by using the top first. So natural log of a plus natural log of x. I'm going to kind of break this up here. Then I've got a division, so that means minus natural log of c, and then I've got the multiplication again, plus natural log, and then I'm going to change this to d to the 1/2. Okay, let's simplify again. So this is still natural log of a plus natural log of x minus natural log of c plus, I've got an exponent, so bring it down, 1/2 natural log of d. I do have a minus sign in front, so I'm going to distribute that to make my final answer. So natural log of a plus natural log of x minus natural log of c minus 1/2 natural log of d. And that would be the final answer. Okay, in order to condense, which most of the time this is going to be the easiest way for you to look at a problem, is the condensed version. What I would do first is, if you notice, you have a coefficient, and coefficient's going to go back up as an exponent. So let's see if we can start simplifying this. So this would be natural log of a cubed. Again, this is a coefficient. So let's say natural log of x raised to the 1/2 minus Now there's no rule that says that I can distribute the natural log. So it's not like I could say natural log of a squared and natural log of 1. So this is going to stay here. So I'm going to say natural log of a squared plus 1. And I'm going to raise that to the 4th power minus natural log of c. Okay, now in the previous problem, you realized that I had a minus and a minus. Okay, and before that, I basically distributed a negative. So let's see what we can do here. I'm going to just jump right into here. I'm going to take all my natural logs out and make one big natural log and see if I can do this. This plus here means that I've got a multiplication. So I've got an a cubed, and this x to the 1/2 is really a square root. A minus means that I've got a division sign. I've got an this 4th power here I can bring to the bottom. So a squared plus 1 to the 4th power. Now, I'm not going to make another division sign. Remember, when I've got a minus and a minus, this means I'm going to multiply times c. And I'm just going to bring that in front just because it's kind of just by itself. And this should be your final answer. Okay, let's see what we've got next here. Okay, the next one says to evaluate. Now, there's a couple of ways you can do this, but I would use my rules. And remember, a minus means to take your logs because they're the same. I'm going to write it as 1. So I'm basically condensing it first. So log base 2 of 80 over 5. And then I can simplify 80 over 5. So this is log base 2. And 80 over 5 is 16. Now I can take this back to an exponent rule and say 2 to the what power gives me 16. And so I know log base 2 of 16 is 4. And you can always take it back to your exponents just to see the answer. Now, why did I not do that here? I could have said 2 to the what power gives me 80 and 2 to the what power gives me 5. And then I could have subtracted those two values. But do we know what 2 to the what power gives me 5? We don't know that. So I went ahead and used my rules to simplify because this wouldn't work. Okay? Okay, so I've given you just this random equation. So if you'd write this down, it says log of p is equal to log of p naught, this is a 0, minus c times log of t plus 1. And I want us to solve for p. Okay, so in order to solve for p, I'm going to try to use my log rules again. Let's see if we can try to just get a single log on each side. I've got a log on the left side, and I'm going to have to apply some log rules before I can get a single log. I'm going to try, I think I'm going to have to move that c first. So log of p naught, and to move that up, I still have that log of t plus 1, and this is going to be an exponent. Remember, you cannot, there's no rule that says to distribute your log in. Okay, so nothing to do here or here. It looks like I can now make one big log here. When you've got a subtraction, that means I've got a division sign. So p naught over t plus 1 raised to the c. And I've got a log over here. Remember, when you have a log on each side, you can basically drop those. So I have p is equal to p naught over t plus 1 raised, or all that raised to the c power. And this is solved for p. So basically, you could manipulate this formula from here and solve for p naught or whatever you wanted to do. Okay. And the last thing I have, I've already seen some of you solve for this, but for those of you who haven't yet, I will help you out. It says find a function of form y equals log base a of x going to the point 1/2 and -1. So remember, this is a point x, y, and if we wanted to go through this point, I would just simply plug these in to this equation. So your y value is a -1. I've got a log base a, and your x value is 1/2. So if we wanted to solve this, not using your log rules at all, I would go back to exponent form. So this would be a to the -1/2 is, a to the -1 is equal to 1/2. So what value would a have to be in order to give you 1/2? A would have to be 2. So now all you have to do is plug it into your formula. So y equals log base 2 of x, and that would be your formula. Okay, bring your questions to class.